Okay, so what we're going to talk about in this next lesson is inverse trig ratios. Now the idea of inverse, you've dealt with this for a long time in algebra. An inverse is basically something that cancels out something else when you're doing algebra. For example, let's say that you were solving the equation x plus 4 is equal to 7, right? Now we know that the answer to x is 3 here, but how did we solve it? Well, the way that we get the x by itself, the way that we cancel this plus 4 is by applying an inverse. We apply the additive inverse to positive 4, which is negative 4, and when we apply the additive inverse to both sides, it cancels and we get x is equal to 3. Similarly, let's say that you have x over 7 is equal to 2, okay? And the answer to this is 14, but let's see why. So you know how to handle this. To cancel this divided by 7, you multiply by 7, and we'll do it on both sides. That's because multiplying by 7 is the multiplicative inverse to dividing by 7. Another way of saying it is this x over 7 is the same thing as 1/7 of x, and 1/7 is the multiplicative, or the inverse. The multiplicative inverse of 1/7 is 7. 7 times 1/7 equals 1, so it cancels it, okay? So additive inverses cause it to become 0. Multiplicative inverses cause it to become 1. So we cancel the 7, and then we get x is equal to 2 times 7 is 14. And so that's what inverses are all about. Another way of understanding inverses is to understand the idea of switching the input with the output, okay? So let's say that I had an equation that was y equals 2x plus 5, okay? And I wanted to identify the inverse of this function, okay? If I wanted to know what the inverse of this is, what I would do is I would put the x here, and I would put the y over here. So then I'd have x equals 2y plus 5, and now I would subtract 5 from both sides, right? Subtract 5, and I'd get x minus 5 is equal to 2y. Now divide by 2 on both sides, cancel, and I would have y is equal to x minus 5 over 2. And so here's the thing, this expression x minus 5 over 2 is the algebraic inverse of 2x plus 5. And so that's basically what we're going to be doing here with inverse trig ratios. It's the idea that we're going to be creating an expression where we're reversing the x and the y, okay, where we're reversing the input and the output. Although in this case, we don't have an x and a y. What we have is a theta and a coordinate, okay? So for example, let's say that I say, what is sine of pi over 3? We know that sine of pi over 3, based on the unit circle, if we go to pi over 3, sine is the y coordinate, so the y coordinate is square root of 3 over 2, and so we get square root of 3 over 2. And in this trigonometric expression, this pi over 3, that's the theta, that is the input. And over here, the output is whatever sine is. So what we're going to do is, in this particular case, we'll call it, the y value. So theta is predicting a y value, okay? Well, what we're going to do with inverse trig ratios is we're going to reverse. What we're going to do is we're actually going to have, so first of all, to indicate an inverse, we're going to write sine, but we'll put a -1. Whenever you put a -1, like to the power of -1 on a function, it's indicating the, well really in some cases the reciprocal, but what it's mainly indicating is the inverse. The reason it's not indicating the reciprocal here is because sine functions or trigonometric functions are what are called transcendental, meaning they don't follow the normal rules of algebra. They have their own rules. Their own rules are based on the unit circle, not based on polynomial algebra. So anyway, we're going to put this little -1 here. So if you didn't understand anything I said for the last 60 seconds, just ignore it. Just understand that when you see sine to the power of -1, that means sine inverse, okay? And now inside the parentheses, instead of putting an angle measure, instead of putting a radian angle measure, we're instead going to put a y coordinate, okay? So the form becomes sine inverse of y is equal to theta. So in inverse trig problems, the answer is an angle measure. Everything we've done up till now has been where this is the question and this is the answer. Well, now with inverse trig ratios, this is the question and this is the answer. So if I say, what is sine inverse of square root of 3 over 2, okay? Now this is, understand, there is more I need to explain to you, but I want to get the basic idea in your head before I go into greater detail, okay? When I say this is a -1 here, it's really ugly, but that's a -1. There we go. If I ask sine inverse of square root of 3 over 2, here's what I'm asking. What I'm asking is this: what angle measure, what radian angle measure on the unit circle would give me an answer of square root of 3 over 2? And so we can go onto the unit circle, but now instead of looking for a radian angle measure, we're going to look for a y coordinate of square root of 3 over 2. Sine indicates y coordinate. So what y coordinate, what angle has a y coordinate of square root of 3 over 2? And we go to square root of 3 over 2 right here, and we see that the angle measure that has a y coordinate of square root of 3 over 2 is pi over 3. And therefore, the answer to this is going to be pi over 3. And that is the basic idea with inverse trig ratios, is instead of being asked or being asked about a y coordinate given a radian angle measure, now you're being asked what is the radian angle measure when I give you the y coordinate. It's just reversing the way that the question is being asked. Okay, so let's try a couple more. Let's do a cosine. So let's say, hey, what is cosine inverse of square root of 2 over 2? Okay, so this is saying what angle measure has an x coordinate of square root of 2 over 2? Well, here's square root of 2 over 2, right? And the angle measure that goes with square root of 2 over 2 is, with an x coordinate of square root of 2 over 2, is pi over 4. Therefore, the answer to cosine inverse of square root of 2 over 2 is pi over 4. It really is that simple. I'm hoping you're thinking, wow, that's easy. All we're doing is, instead of looking at this and then getting this, we're now looking at this and getting this. That's correct. Okay. Now, there is a complication in all of this, and I'm going to explain that. I'm going to explain that to you now. Let's say that we want to know what is sine inverse of 1/2. Sine inverse of 1/2. Okay. Well, this actually creates a problem. You might look at this. In fact, why don't you look at the unit circle right now and see if you can figure out what is the answer to sine inverse of 1/2. Okay. It's saying what angle measure gives you a y coordinate of 1/2. Okay. Now, if you look closely enough, you'll see that there are actually two answers to this problem. In fact, the other two problems that we just did, there were two answers to those as well. And so I'm going to explain something to you. There's something very important you need to understand about which answer to pick. Okay? So here's what I mean. We have a y coordinate of 1/2 right here, right? But look all the way over here on the unit circle. Don't we also have a y coordinate of 1/2? Therefore, the answer could be pi over 6 or 5 pi over 6. That's two possible answers for the exact same question. Well, in math, We usually don't like that, especially if we want to turn this into a function. We need to have only one output value for each input value, and therefore we can't have two answers for the same question. I'm going to make it even worse. Now, if we were to throw in coterminal angles, there would be even more answers, because can't we go around the circle? And wouldn't this then become, right here, if we double the denominator, 12, add 1, that's 13. At 13 pi over 6, which is in this exact same place. So for an angle of 13 pi over 6, the y-coordinate is 1/2. That gives us now we have three answers to the same problem. Well, if we come over here on the second time around, double the denominator, 12 plus 5, 17 pi over 6. 17 pi over 6 is at this spot after one full rotation, so almost 1.5 rotations, and we have 17 pi over 6. That means we have four answers that have a y-coordinate of 1/2. Well, actually, now it gets worse than that, because can't we go back to the start, to 0? And what if we went backwards? What if we went to negative angle measures, right? We learned that we can do that. This point right here, well, this point right here would be negative 7 pi over 6. Remember, when you go backwards and you do the negatives, these angle measures go up here and these angle measures go down here, but they're now negative, right? So this angle measure, if we start here at the initial side and bring the terminal side this way, when we get to here, that angle measure that's created is negative 7 pi over 6, which has a y-coordinate of 1/2. And if we come all the way around to here and we get negative, bring this up here, negative 11 pi over 6, that also has a y-coordinate of 1/2. Now that's 6 possible answers to this question. Now hopefully you've figured out that if we keep turning it, we could wind up having 7, 8, 9, 10, 11, 12 answers to this problem. Ultimately, the truth is that there are an infinite number of answers to this. Because of coterminal angles, because we can keep going around and around the circle, forward and backwards, there are literally an infinite number of answers to this problem. So what we have done in math is we have limited the number of possible answers. Okay, we have limited the range of we've limited the domain. The domain is already limited, but we've limited the range of answers to this problem. And here's what we have decided. Well, someone decided this. I wasn't in the meeting, so this is hundreds of years ago. Somebody decided, maybe thousands of years ago, that for sine, all of the answers are going to fall between negative pi over 2, okay, and theta and pi over 2, including, okay? They're all going to fall between negative pi over 2 and pi over 2, okay? And so here's what I mean. Negative pi over 2 is down here if we go backwards, right? So this is 3 pi over 2 if we go forward. But if we start here and go backwards, then this becomes negative pi over 2, right? Negative pi over 2. This one here becomes negative pi over 3. This one becomes negative pi over 4. And this one becomes negative pi over 6, right? And so now, here are all of the possible answers, really, is everything between negative pi over 2 and leading up to pi over 2. In fact, it's really what it is it's half of the unit circle. Starting here, it is the right half of the unit circle. And these are all of your possible answers. And what that does is, because it starts here at negative 1 and it goes up here to positive 1, it only hits each one of the y values one time if you start here and stop here. Okay? And so, for sine inverse of 1/2, you would then, this would not be an option. 5 pi over 6 is not an option. And neither is going around more than once for 13 pi over 6. There is only one angle coordinate. There's only one theta angle between negative pi over 2 and pi over 2. that has a y-coordinate of 1/2, and that is pi over 6. Therefore, the one and only answer to sine inverse of 1/2 is pi over 6. Okay? And so now, what if I ask you, okay, well then what is sine inverse of negative square root of 2 over 2? Okay? All right, well, where is negative square root of 2 over 2? Well, if we go along the y-axis, negative square root of 2 over 2 is right about here, right? Well, look, we have two sides here. 7 pi over 4 has negative square root of 2 over 2, and 5 pi over 4 also has negative square root of 2 over 2. Well, neither one of those is the answer, okay? Because what I told you is that we're not going as far as 7 pi over 4. We're only going between negative pi over 2 and pi over 2. And you might be saying, yeah, but there it is, 7 pi over 4. Yes, I understand. But you're not allowed to choose 7 pi over 4. You have to go back 2 pi. You have to go back one rotation to a coterminal angle, which is negative pi over 4 right here. So the correct answer to sine inverse of negative square root of 2 over 2, which angle measure has a y-coordinate of negative square root of 2 over 2? The correct answer is negative pi over 4. You have to go to the starting point and go backwards to your negative angle measures until you get to negative pi over 2. So the correct answer is negative pi over 4. Okay? All right? So that is sine. Now let's talk about cosine inverse, okay? Cosine inverse has a very similar phenomenon, okay? See, the problem, let's say I say, hey, what is cosine inverse of 1/2? What is cosine inverse of 1/2? Okay, so we want to know what angle measure, what theta angle measure. Oh, by the way, up here, this is for sine inverse. Sine inverse. Okay, cosine inverse is going to have its own. It's a different one. It's not negative square root of 2 or negative pi over 2 up to pi over 2. So cosine, what theta angle has an x coordinate of 1/2? Okay. Okay. Well, 1/2 is right about here, and you can see that pi over 3 has an x coordinate of 1/2. But if we keep going around the circle, you can also see that 5 pi over 3 has 1/2. And if we keep going around the circle, this becomes 7 pi over 3. That also has an x coordinate of 1/2. And if we keep coming around the circle and we get here to 11 pi over 3, that also has an x coordinate of 1/2. Or we could go to the starting point and go backwards. Look, we can go to negative pi over 3. Also has an x coordinate of 1/2. So we have an infinite number of answers because of coterminal angles. Because we can keep going forward and backwards around the unit circle, we have an infinite number of possible answers. And so what they have done is they have decided that all of the answers for cosine inverse are going to start at 0 and they're going to go up to pi. Start at 0 and go up to pi. Okay? And so between 0 and pi, just these angles, no x coordinate is represented more than once. Okay? And so so we're going to go from 0 up to, so the theta angle for cosine inverse is going to go from 0 up to pi, and those are the only answers we're going to choose. So now the question is, what angle measure between 0 and pi has an x coordinate of 1/2? Okay, well, from 0 to pi, okay, here's, in terms of coordinates, this is 1, this is 1/2, this is 0, x coordinate, right? Negative 1/2 and negative pi. Well, 1/2 is here, and since we're only going to go to the upper half, we're going to ignore the bottom. We're going to go up, and we're going to see that pi over 3 is the correct answer. That is the only angle measure between here and here that has an x coordinate of 1/2. So the answer to this is pi over 3. Okay? And so now let's try another one. What if I were to say, well, what is cosine inverse of negative square root of 3 over 2? Okay? So now that's saying what angle measure between 0 and pi has an x-coordinate of negative square root of 3 over 2. Okay, well this is square root of 3 over 2, not negative. Nope, 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 nope. Oh, there it is, negative square root of 3 over 2. Therefore, the answer is 5 pi over 6. Okay, the one and only answer is 5 pi over 6. Okay, all right. So that is our introduction to inverse trig ratios. What I'm going to do right now is I'm just going to give you a few other examples that we're going to try. I'm going to see if you can figure them out, just to see if you have a feel for this. Okay, so here's 8 examples. There really aren't that many that I could possibly ask you. I mean, it's only like maybe 8 for each of them. Okay, so let's look at the first one. Sine inverse of 0. What that's saying is what angle measure between negative pi over 2 and pi over 2 will give you an answer of, will give you a y coordinate of 0. Okay, I'm just going to get you started on that. What I want you to do is, why don't you pause the video and try all 8 of these now, and then I'll work them out for you. All right, so what angle measure between negative pi over 2 and pi over 2 would give you a y coordinate of 0. Okay, well from here up to here, y coordinate of 0 is right here. Therefore, the answer is 0. It's not 2 pi, because 2 pi is not between negative pi over 2 and pi over 2. 0 is between negative pi over 2 and pi over 2. Therefore, sine inverse of 0 is 0. Well, how about cosine inverse of 0? Now, this is saying what angle measure between 0 and pi gives you an x-coordinate of 0. Okay, well, from 0 over to pi, somewhere in here, our x-coordinate is 0. There's our x-coordinate 0, and therefore the answer is pi over 2. Okay, what angle measure between negative pi over 2 and pi over 2 would give you a y coordinate of negative 1. Okay, well, where's a y coordinate of negative 1? Here's negative 1. Okay, so the y coordinate of negative 1, and we're going between negative pi over 2 and pi over 2. Well, what angle measure is associated with here? Well, not 3 pi over 2, because 3 pi over 2 isn't on this interval. But negative pi over 2 is. And so the answer is negative pi over 2. Negative pi over 2. Okay, all right, cosine inverse of 1. What angle measure on the interval, cosine's interval is from 0 to pi, what angle measure from 0 to pi would give you an x-coordinate, because that's cosine, an x-coordinate of 1. Well, the x-coordinate of 1 is right here, and so this point has 1, 0, x-coordinate of 1. So its answer's not 2 pi, because 2 pi is not between 0 and pi, but 0 is. So the answer is 0. Okay, so cosine inverse of 1 is 0. Okay, now you'll notice something interesting here. Here's a theta angle of 0, and here's a theta angle of 0, and so the fact that you have both of them here, you can see the x-coordinate and the y-coordinate, 1, 0, right? 1, 0, okay? All right, let's do sine inverse of square root of 2 over 2. So inverse means what is the theta angle, what angle measure? And since it's sine, it's between negative pi over 2 and pi over 2. What angle measure between negative pi over 2 and pi over 2 would give you a y-coordinate sine of square root of 2 over 2? All right, well, down here are all the negative y's. We don't want those. We want the positive y's. Here's square root of 2 over 2. Positive square root of 2 over 2. Angle measure between negative pi over 2 and pi over 2 is pi over 4. Okay, so the y-coordinate of square root of 2 over 2 is associated with an angle measure of pi over 4. Okay. All right, now sine inverse of negative 1/2. What angle measure between negative pi over 2 and pi over 2 would give you a y-coordinate of negative 1/2? Well, here's the y-axis. 1/2 is about here. That's over here. Oh, look, a y of negative 1/2. It's this point right here. Well, what is the angle measure at this point? Well, we have a couple of them because of coterminal angles. We're not going to use 11 pi over 6 because that's not between pi over 2 or negative pi over 2 and pi over 2. We are going to use the negative theta angle, though, which is negative pi over 6. And therefore, the answer to this is negative pi over 6. Okay? So now, What is cosine inverse of square root of 3 over 2? What that means is what theta angle between 0 and pi, because it's cosine, would give you an x-coordinate, because it's cosine, x-coordinate of square root of 3 over 2. Well, here's the x-axis, and square root of 3 over 2 is right about here. Oh, there it is. Look, square root of 3 over 2 for an x-coordinate. And this angle right here is between 0 and pi, so the answer is pi over 6. And look, again, oh, actually, no, we don't have it again. This is negative pi over 6. Scratch that. Okay. All right, so now, last one, cosine inverse of negative square root of 2 over 2. All right, so it's saying, because it's cosine and it's an inverse, it's saying what theta angle on the interval from 0 to pi gives you an x-coordinate, because it's cosine, of negative square root of 2 over 2. All right, well, all the negative x values are on the left side, so negative square root of 2 over 2 has to be over here somewhere, and it's got to be between 0 and pi on the upper half of the circle. Well, that's, look, it's right here. Negative square root of 2 over 2, that's our x-coordinate. Well, what theta angle is at this point? Well, that's 3 pi over 4. Is that between 0 and pi? It sure is. So our answer is 3 pi over 4. And that is how we do sine and cosine inverse problems. And you'll get a handful of these to be able to practice. Now what we're going to do is we're going to go on to how to identify inverse trig ratios for tangent, cotangent, secant, and cosecant.